In last video, we have discussed about function and the definition of function along with function notation. The definition of function is a relation between two non-empty set, and function notation is y is equal to fx. Mathematically, we write y is equal to fx, and how we say this line, that we say that y is a function of x. Okay, and we have discussed as well that f is not multiplied with x. F is actually a function of x actually, and instead of small f we can use y is equal to capital F x, and instead of f, if we want, we can use y is equal to gx, or y is equal to phi x, or y is equal to psi x. We can use these notations instead of fx, y is equal to fx. So in all the mathematical expression, we say y is a function of x. Now next one is we are supposed to discuss infinite number and infinitesimally small number. So these two terms are very important. First one is infinite number. Infinite number, that is, suppose if we write 1 triple 0 0 0 0, there's so many zero, and if I ask that is it a infinite number, the answer is it is not an infinite number. Why it is so? Because we can write bigger than this. We can write can we write greater than this? So answer is yes, we can write greater than this by adding zeros. We can add zeros, more zeros, so that it become greater than the earlier one. So is it the greatest one? So answer is no, it is not greatest one. So can we add more numbers? Yes, we add more zeros and it become greater than the last one, the previous one. So is it the greatest one? So answer is no. We can add more zeros so that it become more, means greater than the previous one. So finite number means which is undefined. We cannot define that number. We cannot write on piece of paper, okay, that number. So that number which we cannot write on a piece of paper, that is called infinite number. Similarly, infinitesimally small, infinitesimally small number. Okay, if I use 0, 0 and then point, then I use so many zeros and then write 1. So is it the smallest number? This is the question. Is it the smallest number? So answer is no, this is not the smallest number. We can write smaller than this. We can add zeros, so many zeros, and again use 1. So is it the smallest number? So answer is no, this it is not the smallest number. We can add more zeros. We can add more zeros in this number, and okay, and we can write 1 after at the end. So is it the smallest number? Answer is no, it is not the smallest number. We can add more number, we can add more zeros, and at the end I can use 1. So is it the smallest number? So answer is no, it is not the smallest number. We can add more zeros and at the end we can write 1. So it means infinitesimally small number cannot be written on a piece of paper. Suppose x is the smallest number, it tends to 0. It tends to 0, but it is not equal to 0. It is not equal to 0. So infinitesimally small number is a number which cannot be written on a piece of paper. It is so small that we cannot write on a piece of paper. It tends to 0, but it is not equal to 0. This is the definition of infinitesimally small. So these two terms must be clear, okay, so that we can understand derivative.